All right. So happy 4th of July to anyone who celebrates it. So this morning of July 4th, I was going through the videos that I had on Java versus Rust and realized that I did not post about how they are different compared to Java versus Rust during runtime, right? So runtime does play a very important factor when any program starts for the first time or gets copied over for the deployment and all. And I thought I should do some high level uh, on what I know on how these compiled and all, right? So yeah, this video will be a very short video, hopefully. Because I don't know. As you can see my videos, it's pretty raw. I didn't go and set up all the lighting and all. As long as you can hear me fine, yeah, understand what I'm saying. Hopefully you're understanding what I'm saying. Um, but yeah, let me actually start with what I have on my end gathered, with some help from AI, obviously for the fancy diagram and all. Yeah, let's start with that actually. So, let's see. Okay. So I actively code in Java, and Rust is my personal favorite, right? So on the weekend I do some, or weekend or anytime I'm like free from everything, I go play with Rust. But these two things actually stood out for me before I go into the runtime side of things, right? So um, let's say you have to, let's imagine you are a developer, right, for the first time, who wants to learn Java. So what do you have to go through? So first thing you'll have to go through installing JDK in your machine. Um, which version to choose have to be decided as well, depending on what type of project you are going to build, right? So not all packages, libraries that you use might support 17 or 21. That's something you have to decide. Um, well, obviously, there's the environment variable that you have to set up on the Windows machine or Linux or Mac, or whichever you use. And then you'll have to choose Maven build, Gradle, whatever you use to build the compile the code, right? Then obviously you have to set up IDE. This obviously applies to Rust as well. You have to configure dependencies heavily on Java side of things. Rust you do, but it's less involved compared to the Java. And then version conflicts, class path problems. Rust has less class path problems compared to Java. There's no doubt on that. Version conflicts, obviously, Rust you have to maintain it, and then you just finally write a hello world, and then that's it. So for the Java developers or anyone trying to start, they have to go through too many steps, right? But let's say you wanted to start the Rust side of things. Let's say we have a new developer coming in. They want to learn Rust. First thing they would do is get the Rust setup locally, install Rust command. If it's Windows, it has its own way. Linux, Windows, I think it's pretty easy. The command that you are seeing here is through curl because I took a help from AI to generate this video, right? But AI doesn't mean it's always going to be right or they know the context. Or maybe I'm not like prompting it correctly, but you don't really have to go through curl and all. You just can go to Rust website, download it, run, install Rust. Right. So once you install Rust, uh, You can either install an IDE like this. A Rust rover is what I use here for the project that I do here. Um, and yeah, you just write a hello world and you run it. The good thing is you don't have to worry about installing like build tools such as Maven and etc. Right? So you write a hello world, you build a hello world, go to that project itself, right? And then you just run it. Um, and internally everything is handled for you. You don't have to worry about if I'm using Windows or what should I do. I don't have to worry about building or setting up environment variables and all. But yeah. So this is in context to how developer would uh, have to go through. There's more than that, right? Obviously, but at a very high level, these are some steps to get started actually. All right, now let's switch to the main topic that I started this call on, the runtime cycle and runtime cycle on Java versus runtime cycle on Rust, right? So, um, anytime I write a Java program, I run it. Like so, let's say you run this program, and if you look here, you have to build it, right? So what's happening? So you'll see that uh, whatever you wanted to see the output on, you see it in the console. But how are you seeing it? Um, so for the Java side of things, right? So once you write your Java code, it's compiled into the bytecode. It's not zeros and ones yet, but a bytecode that a JVM can understand. So that JVM will will understand your bytecode, and that bytecode will be assigned to some memory management, right? So these bytecodes execution and JIT comparison, just-in-time compilation happens pretty much at the same time. Now they assign the memory allocation because Java has to go through garbage collection, right? That way it can manage the memories, free up the memories, and obviously it also have to manage the syncing of those memory location. And there you have it. So, then you see it on your end like an output like this. Um, that's for the Java side of things. And if you go to Rust, um, let's go to the Rust. You write a .rs file. So Java has .java extension, and then the Rust has .rs files. You write that code. Once you run that code, Rust is already set up that way that it knows if you're running on Windows, if you're running on Linux or any other operating system. So now what happens next is it generates the um, machine level bytecode. So if you go back to Java, you'll have to go through bytecode execution, JIT, memory management, right? And then this is when it's closer to the machine. Here on the Rust side of things, you write that code, everything is taken care of you right away, right there. And then the machine generated code. The real bytecodes are generated. And then on the Rust, we didn't have any garbage collection. So it will be a memory management uh, that's done by the objects, well, the ownership of the particular. So every object has their own ownership that they decide. Um, objects has Objects are given more control in Rust compared to Java. The JVM has more control on memory management on Java. On Rust, objects are given more control on how they manage. And obviously, concurrency has to be there. So concurrency on Rust and Java Seems to be more similar, but the Java is closer to like C++. So yeah, there you have it. And then, like I said, uh, the Rust, right? So when it builds, I didn't even have to tell, hey, Rust, go and build this for me, right? So as you can see, this .exe, it knows that I'm on Windows and it generates a exe executable file here. I copy this and run it on another window machine. I'm good. I don't have to worry about setting anything up. I think this is something that is actually leading Rust on the front end of programming, uh, and I even see big companies actually switching to Rust. I don't know how it will look in 5 years, but I can see that if Rust goes this way in 15 years or so, I think Rust will be the number one programming language that big companies use job wise, right? So and for the let's go to Java side of things. So I built the program, right? So now I built it as a jar or var, however you program it on your POM file. Now if I copy this and were to go onto a Windows machine and run it, I just cannot run it. I'll have to set up like the GRE at least that way it runs, right? So um yeah, these are some differences at a very high level. And thank you for sticking all the way to the end of this video. Hopefully you learned something. Uh, and happy 4th of July. All right, bye.